Hi there, everybody. My name's Nick Clay from Arrival. I'm sat here in the UK today. It's a shame we're not all sat in Germany together, but hopefully we'll be able to see each other next year. So, as I said, I'm from Arrival. What I'm going to talk to you about today is what we're doing here at Arrival, why we're doing it, and a bit of our experience from Robopilot, which is one of our sort of core autonomous vehicle programs here in Arrival. So, a little bit first about who Arrival are. So Arrival are a startup that's about 4 or 5 years old now. We've been going since 2015, and I joined the company in 2016, and we've recently been voted LinkedIn's top UK startup, and announced a couple of weeks ago that we were going to be hitting the stock market in 2021 with a valuation of $5.4 billion, which was quite impressive for a company that started off as one guy with a vision to change mobility. So who we are as a company, we are developing best-in-class solutions for mobility services for cities to help them meet their zero-emission goals. So this means working closely with operators, with authorities, to help them put in place the infrastructure that they need to hit these targets. The transport system we're developing includes not only the vehicles themselves, but also the infrastructure that goes with them and the back office software systems as well. The 2 vehicles you see here will be our first products to market on our sort of medium-sized van platform and our larger heavy bus platform as well. And I think, you know, probably one of the unique things about Arrival is that we're incredibly vertically integrated. So all of the core components, such as powertrain and high voltage battery systems, are all our own, developed in-house. And going with that is all of our software services as well. So they're also in-house. So we're about 1,500 people, and the technical guys are probably about 50-50 split between hardware and software. All of our vehicles are built off a modular platform with grid-based components, so that it makes upgrading and changing fairly easy. And all of our materials are sustainable as well. So they're all developed in-house to be low energy for manufacturing, but also easy to recycle at the end of a vehicle's life. In terms of what we're going to offer the market, we offer ultimately a turnkey solution for mobility as a service, or any one of those aspects. So we can offer fleet as a service to local authorities, or we can offer vehicle-based solutions, or just infrastructure-based solutions. And ultimately, we're disrupting a space that has been constant for 20, 30, 40, 50 years now, and hasn't really changed a lot in that time. And this was sort of seen by our founder as an area that was right for someone to come in and do something a bit different and apply new technology in a new way. And one of the big things that makes this possible is our micro factory concept, where we will build smaller 10,000 square meter factories globally, rather than centralizing 1 or 2 factories to fulfill demand. And the vehicles will be built in robotic cells rather than on a traditional production line. And this allows us to move fast and respond to market demands, and also to change configurations of vehicles and products quickly, rather than having a huge infrastructure to start with. And all this is possible because we started literally with, you know, one guy back in 2015 and a clean sheet of paper of, you know, if you were building a car factory, how would you do it today? So we have no legacy. We have no legacy buildings that we've gone into. Everything is a clean sheet of paper. The first factories will be in the UK. So this will be our van factory in the UK, that will produce about 10,000 vehicles a year and come on stream in early 2021. And then Rock Hill, South Carolina is our first US factory, and this will build our bus product, which will go into production Q3 2021. So the vehicles are the Arrival van, which is a zero emission urban logistics vehicle. So it'll have a range of anywhere between 80 and 200 miles, depending on what application you choose. And then the Arrival bus, which is a M3 Class 1 city bus, which will go into fleet trials early next year. But the main thrust of what we're here to talk about today is Robopilot, which is our sort of Halo autonomous vehicle project that's been going since 2018. We actually applied for funding for a UK government call back in probably about October 2016, and sort of by the time the process had worked its way through, we were awarded funding and started the project in January 2018. And at that time, when we first applied for funding, Arrival were about 35 guys in the UK and a similar number of people in St. Petersburg as well. And you know, we were unheard of and you know, an unknown to the industry. So for us to win a £12 million government funding project was you know, pretty important for us and pretty key at the time. It let us really work on our relationship with key partners like UPS, who have been with us since the start and have sort of come on the journey with us. And you know, that's the fruits of that are seen in sort of the orders that they've placed with us already. There's other partners involved as well. So because Arrival are vertically integrated, the technology stack stays with us, but our partners have really helped us around the testing and validation and application of new validation methods to help ensure that when we go to our on-road trialing, that we're doing so in a safe and robust manner, backed up by a safety case that's built on solid foundations. So Robopilot is an autonomous vehicle project that all started back in 2016 when Arrival set up RoboRace. RoboRace, you might all be a bit more familiar with, is an autonomous racing series that first found prominence back in 2017 at Goodwood, when we became the first vehicle to drive the Goodwood Hill autonomously. And this was an incredible feat of feat of engineering and software for us. The vehicle was built from scratch, the software was built from scratch, everything started from a blank sheet of paper and sort of, you know, one guy's vision to disrupt the world of mobility. And the RoboRace effectively formed the platform for Robopilot, which is our road-going autonomy stack. To tell you a bit more about Robopilot, it's a project based in the southwest of the UK, and will deliver depot autonomy, which is probably the nearest to market autonomy solution that we see here at Arrival. It allows operators of big fleets to massively improve their safety and efficiency of their depot operations by being able to move vehicles around without the need for human intervention. So this will massively reduce the number of collisions they have in depot, which tend to be minor low-speed collisions, but can result in expensive damage and frequent damage to vehicles, which takes vehicles off the road and causes further expense further down the value chain. And then the second aspect is a 10-mile drive on public highways, which for anybody who's ever been in the UK, to get 10 miles of public highways without some significant challenges is pretty difficult. And the funding call from UK government focused on that and requires 10 miles on mixed roads in mixed traffic. So there's no getting around the fact that it's a pretty big challenge for us and our partners to deliver that safely. So we're working with Bristol Robotics Laboratory and the University of the West of England and University of Bristol on the simulation side, and a test bed built by TVS. And all of that is based on accidentology research carried out by Loughborough University. So they've delved into the Stats19 accident database to come up with the frequent accidents and accident research that like commercial vehicles have, so we could apply that to ensure that we covered the right safety cases and accident methodologies during our simulation activities, which we could then validate on a test track in controlled conditions. And from a cybersecurity aspect, Thales have worked on that and advised us and helped us develop our cybersecurity coverage. So this all then, how it manifested itself, sort of after a long period of sort of testing and and simulation was in our first sort of rig build, which was the middle of last year, which started off on very slow movements at our Banbury facility. So this is outside of the facility I'm sat in today, and this was sort of very much our first foray with a real living road vehicle. So it's based on a platform we had here at arrival, with a van frame on it, so all the sensors could be mounted in the right position. But it just let our guys start work and practice our trajectory and route planning in a relatively benign environment before the challenges of moving to an actual physical depot came in. So we then move on to the latest of where we are today with this. So this is our this was last week at the UPS depot in Bristol. So if I hit play on the video, I'll talk you through what's happening. So the ultimate goal is that you can have a sterile depot environment. So no vehicle movements at all, and so the vehicle can drop the driver outside and drive into the depot, and then do the vehicle movements within the depot, such as dropping off the parcels, and then move to perhaps the wash bay, move to be loaded with a different set of parcels for the next day's drop-offs, or go to the maintenance bay if it was needed. So all of this is done at low speed, which makes it a really nice application for autonomy, because it reduces the risk considerably. But actually, in terms of a route to market, it's pretty straightforward. But UPS have some pretty tight restrictions on how they operate to reduce health and safety issues in the workshop. One of them is that vehicles have to be within 5 centimeters of the loading bay, which, given sort of accuracies in positioning and vehicle movement, is actually quite a difficult challenge for us. So there's a reasonable amount of tuning involved there. The other aspect is that because of the makeup of the depot, we can't rely on GPS signal indoors, and to avoid having to add additional hardware into depots, we made sure that our vehicle was capable of being able to locate and fully use its onboard sensor set rather than relying on GPS signal. So all of the movements that you see here are not using GPS at all. It's purely using the vehicle's onboard sensors to work out its positioning and to maneuver itself around from point to point within the depot. The next phase of this involves more obstacle detection work. So initially, we were focused on making sure we could maneuver around the depot from one point to the next. And then in a couple of weeks, we start testing with obstacles as well, to make sure that if packages or parcels or people end up in the way, there are people working inside the depot to make sure that the vehicle is able to avoid them and take the right course of action. Just let the vehicle return itself back into the depot. There we go. So where this then leads on to early next year, is we move to our on-road trialing phase. So we take all of the simulation work and the test bench simulation work that we've been doing with our validation partners, and we move to on-road trials. So the simulation work that we've been doing already has been focused on a lot of the urban roads around Bristol, where we'll be driving our trialing program. Here you'll see some of the early simulation work that we did before we've inputted the smart actors and numerous different hazards into the simulation. But again, this is, as anybody who's ever driven in the UK will know, UK roads are incredibly challenging in urban environments, because there's very rarely any consistency, and there is very rarely any consistent discipline in lane movements and things from other road users. So we live in envy of our colleagues in America, who have much wider roads and much more constrained junctions to play with. But yeah, this is a really big challenge for us here at Arrival. So we won't pretend that the 10-mile route that we're going to follow here, which starts starts at point A here on Bristol and Bath Science Park is going to be a seamless 10 miles of autonomous driving. There'll be planned disengagements for complex junctions and some of the roundabouts where we can't necessarily robustly ensure that we can cope with all possible cases of other road users' usage of the infrastructure. So some of the approach angles make that difficult. So the angled approach angles on the roundabout you see here in the top right make it particularly tricky for us. Making sure that we can cover all angles of approach that might be taken by particularly motorcyclists is difficult. So chances are, I think that roundabout is probably going to be a planned disengagement for us. And the one in the bottom left, which was you saw at the start of the simulation, is might be a UK specific complexity, but it's a double mini roundabout, which is I think probably going to end up being a nirvana for our autonomous software guys, because if we know we can tackle that safely and robustly, then I think the world is our oyster in terms of our autonomous driving capability. And just generally, there are some reasonably complex junctions where I think we'll have some planned disengagements. But we just wanted to share some of those with you today to perhaps share some of the challenges that we're having, and maybe during the Q&A we can discuss a bit more about how industry as a whole can tackle some of these really complex junctions. So that's probably just about me for my time today. I think to leave enough time for questions afterwards. So I'll sign off at that point and look forward to the Q&A.